These are solutions for the diagnostic test Endterm. Question 1. The mean height of 10 boys in a maths class is 179. The mean height of 15 girls is 172. Explain why it's not 175.5. So to explain why it's not, why don't we calculate the actual total mean? Okay, notice that there's 10 boys and 15 girls. So we know already that it doesn't make sense to just average these two averages like was done to get the 175. I need to do a little bit more. So if I just look at the boys, okay, I know that the mean is 179, and I know that there are 10 of them. Using my formula for mean, I should be able to substitute in the values that I know, okay, and solve for this total sum of scores. Okay, so if we lined all the boys up together, they would be 1,790 centimeters long. Okay, I could do a thing for the girls as well. Okay, their mean is 172. There is 15 of them. Using my formula, okay, I can solve for the sum of all of their heights, okay, whatever this is. Okay, so if I want to look at the whole class, okay, I know that there are 25 students, and I know that the sum of all of the heights is whatever the boys plus girls sums are, so 1,790 plus 2,580. Okay, so 4,370. So to find the average height of the total class, I can use my formula. And I get 174.8 centimeters as the mean height of the total class. Okay, so I can write like a little explanation here if I want. Okay, I could say the mean height is actually 174.8 centimeters. Okay, finding the mean of just 179 and 172 doesn't take into consideration that there are more girls than boys in the class. Okay, and we can make another comment and say that because there's more girls, we expect it to be lower than 175. Okay, there are more girls, and the mean girl height is lower than the mean boy height. We expect the class mean to be lower than 175.5. Okay. Question 2 requires a little bit of experimentation to show some possible data values here. So the information we have is the median of 6 values is 8. Okay, so I know we're going to have 6 values. Okay, since there's 6 values, we know that the median is going to be the average of these two scores. So we need to make sure that they that these two in the box are going to average or have the mean of 8. Okay, it tells us that the mode is 7. So to have a mode of 7, okay, we need at least 2 7s. Okay, so I'm going to put the 2 7s just in here. Okay, 7 and 7. What else do I know? So I know the mean needs to be 9. Okay, so if I know the mean is 9, I know that I have 6 scores. Okay, I should be able to use my formula to find out what the sum of all these scores should be. So the sum of all the scores will be 9 times 6, okay, 54. Okay, so all scores need to sum to 54. Okay, so the way we'll do this is, I don't know what this value is. Okay, I don't know what this value is or this value is. Okay, since the median is 8, okay, I can say that the next term needs to be 9. Okay, since 7 plus 9 on 2 equals 8. So I know that's 9. Now I just have to play around and try and find what B and C could be. Okay, so I know that x plus 7 plus 7 plus 9 plus B plus C, so adding all these together, okay, I should get 54. Okay, so I can rearrange this and get these three need to add to 31. I'll see if I can think of some other conditions on here. So my x value needs to be less than or equal to 7. Okay, so let's just, for example, let x equal 6. Okay, and we can play with that. Okay, so therefore B plus C needs to equal 25. Okay, just taking away that 6 from there. Okay, and I also know that B needs to be greater than 9. Okay, otherwise what would happen? Okay, 7 wouldn't be the mode. Okay, and I need C to be greater than B. Okay, otherwise, again, 7 wouldn't be the mode. Okay, so from here we can generate some 2 using these conditions. So B needs to be greater than 9. So I could say, for example, B equals 10, C equals 15. Okay, we'll think of all the other combinations I could have. B equals 11, C equals 14, B equals 12, C equals 13. Okay, and that's just looking at the integers. Okay, so possible responses. Okay, I could have 6, 7, 7, 10, 15. Or 6, 7, 7, 11, 14, or 6, 7, 7, 12, 13. Okay, but remember, if you're being really systematic, okay, where it's highlighted here, okay, I could also say could be 5, 4, 3, 2, 1 or 0. Okay, and that'll generate even more possible combinations down here. Okay, so that's the sort of answer that you get from here. So this isn't the totality of it. You could generate a lot more solutions. Okay, question 3, maximum temperatures of 2 towns are shown. Need to draw parallel box plots for the data. Okay, just remember our rules. So the median is n plus 1 on the 2. Okay, and to find Q1, if there's a even number of scores, okay, it's at n plus 2 on 4. If there's an odd number of scores, n plus 1 on 4. Okay, so I need to draw parallel box plots for the data. So that means I need to find the Q1, Q2, Q3, and the maximum. So I'll do it by hand for town A. Okay, since I'm showing full calculations, I'll need to put these in ascending order. Okay, in both scenarios, n equals 14. Okay, so I know that the median is at n plus 1 on 2, so it'll be at the 7.5th score. Okay, and Q1, since n is even, will be at n plus 2 on 4. Okay, so it'll be the 6th, the 16 on 4 will be the 4th score. Okay, so I should be able to identify these. So 1, 2, 3, 4. This is Q1. 5, 6, 7.5. Okay, so it'll be the average of these two, which is 28 for the median. And to find Q3, count from the other side. 1, 2, 3, 4. There's Q3. Okay, now that I've found all of those statistics, I can go ahead and draw my parallel box plots. Okay, need to start with an axis on the bottom. Need to go between 22 and 35. Okay, so hopefully I'll get enough room for all of this. You should use a ruler. Okay, I'll just shorten that. All right, and I'll go ahead and put all these details on. So for town A, got my minimum score, got my Q1, my median, my Q3, and my maximum. Okay, and then I can draw the box and whisker plot around this and write here that it's town A. And then do a similar thing for town B. Okay, from here, there's a whole heap of things we can say to compare the two towns. I can start by looking at the extreme values. Okay, so I'd say that town A has the hottest and the coldest day. Okay, as we see that the maximum and the minimum are both in town A. I could talk about measures of central tendency. Okay, so if I look at the median, which is the only thing I can compare here, the median of town A is above the median of town B. Okay, so on average, town A is hotter than town B. Okay, higher median, and I'll quote the scores as well. 28 versus 27. And I'll look at the measures of spread. Okay, town A has a larger range of scores. Okay, 13 versus 7 in town B. And we can also talk about the interquartile range. Okay, town A has a larger interquartile range, 6, compared to town B, which only has 3 as the interquartile range. Okay, so for these ranges and interquartile ranges, max minus min, or Q3 minus Q1. Okay, you just show those calculations as well. Is there anything else we can say? And remember, we always want to make one sort of, I guess, special comment about some of these quartiles. So if we look at the lowest quartile of town A, okay, it's lower than all of the scores of town B. So I could say something like the coolest 25% of days in town A are cooler than all of the days in town B. Okay, so we'll always try and make some comment like that, making reference to some of these quartiles. Question 4 is predominantly a graphics calculator question. So given 2 bits of information about insurance policies. So it says Theo and Martin both sell insurance for the same company, shows their performance over 11 months, calculate mean and standard deviation for each. So I'll go into start mode, hopefully it's empty, yep, and I'll type in this data. So this 0, 1 means 1, okay, 1, 3, 13. I'll just enter in all this data. Okay, so I've got 11 scores. I'll just check on here. 1, 2, 3, 4, 5, 10, 11. Yep. Okay, I want to do some calculations. I just need to check it's set up properly. Yeah, list 1, and it's not in a table, so frequency of 1, all good. 1 variable calculations. So this Theo, his mean number of sales is 20.73, okay, and standard deviation is 10.17. So I'll write that down on my sheet. And remember, you'd only use this second standard deviation if you're trying to use this to estimate estimate what Theo would do for his whole life if he was selling. Okay, if you just ask for standard deviation, just the first one. I'll do the same thing for Martina. I also make for quality YouTubing. Okay, she's got more scores, but it's okay. We'll just set it exactly the same. Okay, I get 20.45 and 5.36. Okay, so this is Martina. So that's part A complete. Part B says to make some comments on their sales records. So the comment I would make would be that Martina and Theo have approximately the same means. Same mean, number of policies sold per month, which indicates they are about the same in levels of skill. Okay, but when we look at the standard deviation, we see that Theo's standard deviation is significantly larger than Martina's. Okay, so I'd say Theo has a larger standard deviation of results, and therefore is less consistent than Martina. Okay, so that would mean that he's sort of less reliable to make sales on a weekly basis than Martina. Okay, a bit more all over the place, and we can see that Theo had 1 week where he only sold 1 insurance policy, and a week where he sold 44. Okay, so we're saying that there's more variation. Okay, we could also support this by just looking at the ranges. Okay, so this is supported. The range of Theo's scores is 43, and the range of Martina's sales is 23. Okay, Theo, there's a lot more variation in the results from Theo. But here, less consistent and reliable. So we want people that come to work and sell basically the same things all the time, so we can budget and plan for them. We've got people all over the place. It's very hard to plan for. All right, so we've got David, 198 centimeters tall and weighs this amount. Easy information to determine whether he's thin or fat compared to the population. Okay, so what we'll do is we'll find a Z-score for his height. Okay, basically to see how many standard deviations he is above or below the mean. Okay, remember it's score minus the mean divided by the standard deviation. So he's 198, the mean height is 174, standard deviation is 18. Okay, put that in my calculator. I'll get about 1.33 standard deviations above mean. Why is it above? Because that's a positive number. and you can also see that he's 198, the mean's 174. We know that he's above. Do the same thing for weight. Okay, so he weighs 104 kilos, the mean weight is 84, and there's a spread of 13. Okay, so this ends up as 1.54 standard deviations above the mean. Okay, so this is sort of like comparing two subjects. Okay, so how well does he do? Is he good at being tall or is he good at being heavy? He's better at being heavy than he is at being tall. Okay, so our conclusion, unfortunately for David, is that David is more standard deviations above the mean in weight than in height, and therefore it is likely that he is thin or fat. He's overweight when compared to the population. Okay, overweight because he's better at being heavy than he is at being tall. Okay, assuming that he's not, a bodybuilder or anything like that. Okay, question 6 is about instantaneous and average rates of change. So for part A, estimate the rate of water loss after 1 hour. Okay, after exactly 1 hour. Okay, so I go up to where 1 is. Okay, assume that's at 1. Don't be tempted just to read this off. Okay, this would be how much water is in the container after 1 hour. Okay, at this point 1, we want to draw a tangent line. I don't have a ruler on me. As best we can, draw a tangent line. Yours will look better than mine. Okay, and we want to find the slope of that tangent line. Okay, so the instantaneous rate of change, okay, is the slope of that tangent. Okay, so the way we'll find this, okay, is we don't have any variables here. I'll call this the water level and this the time. It'll be the change in water level divided by the change in time. Correction, I'll call it volume. Okay, so I need 2 convenient points. So are there any ones that look pretty nice? I'll definitely choose this one. Okay, the 1 and not quite 5. Okay, I'll call this like 4.6. Okay, and I'll choose another point that's relatively convenient. Okay, maybe this point here that I'm going to say is on the line. So 2 and 2.6. Okay, I might be off, but it's just for demonstration anyway. T1, B1, T2, B2. Okay, so I'll note these down the bottom. Okay, from here, I just want to find the changes between these. So ended up at 2.6, started at 4.6, and ended up at 2 seconds, started at 1 second. Okay, difference between these two, -2 and 1, will be -2. Okay, so -2 litres per hour, okay, which means the rate of water loss would be 2 litres per hour. Okay, rate of loss is 2 litres per hour. Okay, since this negative is really meaning a loss. Okay, for part B, what's the average rate of water loss for the first 6 hours? Okay, from this starting point to this point here, I want to find the average rate of change. Okay, so the average rate of change is just going to be the slope of this secant between these 2 points. So I'll call this 0 and scale's pretty bad. 0 and 6 point something. I'll call it 6.8. Okay, and I'll call this point 6 and 0.8. Okay, so I want to find the average rate of change. I've got these 2 points, 0, 6.8, which I'm going to call T1, V1, and 6, 0.8, which I'll call T2, V2. Average rate of change in volume over time. They're my Y and X axes. Okay, write the rule, substitute in. Alright, so I end up with 6 on 6, correction, minus 6 on 6, or minus 1 litres per hour. And I'll write some statement here as well. Average rate of water loss is 1 litre per hour over the first 6 hours. Okay, so remember in these average rate of change problems, we don't care about what happened down here at all. All we just know are those 2 points, and we're finding the average rate of change between them. Okay, some of you may have forgotten how to do this on your calculator. Draw a table of values for the gradient for the curve drawn. Okay, there are notes in your notes on how to do this. All right, I'll type in the function. I'll make a view window that looks roughly like the one on the screen. Otherwise, I'll just zoom in and out until I can see what's going on. Okay, I'll draw it. In setup, I need to make sure that derivative is on. Okay, and then when I draw this thing, to find the slope at all these points, I'm going to go into Sketch, I believe. Okay, and I'll press tangent, and this will give me the slope at all these points. Okay, so that was Sketch and tangent. Okay, I better do it again. Okay, and I can arrow left and right to find the slope at all these points. I'm interested in a table of values from -2 to 3. So to find it at -2, I'll just type -2 as the x value, and it'll show me the slope at -2. If I want to find the slope at -1, okay, there's my slope. The dy dx is the slope, 7. Okay, slope at 0. Okay, it's flat at 0. Okay, so I'll go through from -2 to 3, and I'll make a table of values. Okay, part B, use the information from part A to draw the gradient function on this graph. That should probably say of this graph. Okay, so if I want to draw the slope function of this, so I've drawn that horribly, that's all right. Okay, I'll draw up my set of axes. I need to go up to 3. Okay, and for the slopes, I need to go up to 20 and 15, so 5, 10, 15, 20. So at -2, the slope is 20. At -1, the slope is 7. At 0, the slope is 0. At 1, the slope is -1. I forgot about you. At 2, the slope is 4. And at 3, the slope is 15. Okay, and then I can do dot to dot. Okay, and there's my gradient function. So this is my x-coordinates, and this is my gradient on the y-axis. Okay, does it make sense? Yeah, this sort of tells the same story. Gradient's pretty much always positive, except in this little section here, where we can see it in that little section there. Okay, and where is it flat? It's flat here and flat here, which we can see there and there. 2 flat sections. Okay, but in this example, you don't need to do that because you've used your graphics calculator to find those values. Okay, part C says, use a numerical approach to confirm the value of the gradient at x equals 1. So this is asking us for the instantaneous rate of change at x equals 1. Okay, so to find instantaneous rate of change, remember we've got this formula. We know that the function is x cubed minus 2x squared plus 4. To find the instantaneous rate of change at 1, it's going to be y of something slightly bigger than 1 minus y of 1 divided by the difference between those 2 points. Yeah, it should be routine by now. So off to the side, I'll substitute in 1.01. Okay, find what that is and do the same thing for 1 as well. Okay, find whatever these two values are and they'll go on the top line. And then it's just substitution from here. And hopefully we get minus 1 as our result. Okay, so I get minus 0.9899, okay, and I'd make some statement down here to say that that's approximately the same as the gradient. Okay, so the approximation is pretty close. Okay, you could even do some of these ones, okay, close to minus 1. Okay, just make sure you write some words to show that you know what's going on. Can't they see I'm trying to do math here? I'll call her back, don't worry. Alright, so we've got this velocity time graph. I've drawn it separately down here so I can sort of play with it. Ta-da! How did that get there? Okay, sketch the displacement time graph for the velocity time graph, given that the particle started at the origin. So I need to draw a displacement time graph, okay, using this velocity time graph. So I know that this graph here, this one, slope of, now remember this graph is the slope of the one above it. Alright, so I need to sketch displacement time. I know it starts at the origin, so it starts here. Okay, start at the origin means that point's there. Okay, and this is telling me that the slope is negative at all times. Okay, so at the origin, the slope is negative. It'll lead to some point where the slope's negative all the way. Okay, the slope is always the same and it's always negative. Okay, so I might just make it a little bit less steep so I can actually draw it all the way, but all these points are just indicating the same negative slope. So my displacement time graph, okay, will go through this line. Okay, negative slope all the way. So start at the origin. We'd have some coordinate system set up where this is the start point and the dude standing here, oh, it's a particle, whatever, this guy, this is the positive direction, this is the negative direction. He's just walking that way at a constant velocity, okay, walking in the negative direction, getting further and further away from the origin as time goes on. Okay, remember that linear functions have flat line slope functions, because regardless of where I'm standing on this line, the slope is exactly the same. Okay, y equals mx plus c, all those sorts of things. Okay, question 9, given a sequence described by this thing here means to find the next term, take the current term and multiply it by a half. Okay, and they tell us what the first term is. Find the sum of all terms of this sequence. So I know the first term is 18, and I know the common ratio is going to be a half. What do I need to find? The sum of all values, all terms of the sequence. Okay, I've got A and R, should be straightforward. The sum of all terms, A over 1 minus R, sub these in. I should get 36. Okay, sum of all terms. And you can check it just by adding a few of these. 18, next term would be 9, plus 4.5, plus etc. And you'd see that you get roughly 36 if you wanted to check it. Okay, part B, pendulum is set swinging. The first oscillation is an angle of 30 degrees. So my first thing is 30. Each succeeding oscillation is 95% of the one before it. So I'm going to multiply each one by 0.95. What do I need to find? After how many swings will it be less than 1 degree? Okay, so I need to find when is this term equal to 1 degree. Okay, and then make some judgment based on less than, greater than. Okay, so this should be reasonably straightforward. Okay, remember we've got our formula for the general term. Okay, so the general term in this scenario will be 30 times 0.95 to the power n minus 1. Okay, and I want to know when does that equal 1. Okay, so I'm going to sub in Tn equals 1. Okay, and I'm going to solve for n. Okay, solving this using logs. Okay, a few different ways you can go about solving it. I'd divide both sides by 30. Okay, and then convert to a log statement. Okay, remember unknown power, need to use logs. That unknown power has a log of a base 0.95 and we're trying to get to 1 on 30. So the n that I'm after would be this value plus 1. Okay, so I'll get n equals, I think it's 67.3. Okay, I can't have 67.3 swings. Okay, so I need to round this up because my angle's getting lower and lower. 67.3 would get it to exactly 1. 67 swings wouldn't be enough. Okay, 67 swings is not enough to get the angle to 1 degree. So would need 68 swings. Okay, I forgot to say a pendulum is like a swing, okay, going back and forward, and we're talking about this angle that it makes with the vertical line. Okay, but so you didn't really need to know that context anyway. Okay, question 10 is talking about the global financial crisis and the value of artwork falling. Okay, falling by 8% each year. So hopefully when you see it falling by a certain percentage each year, you automatically think exponential functions. Okay, so we'd define some variables. So it'd say let the value be v. Okay, and let the time be t. Okay, and we're going to have some model that's like our k a to the power x, but we'll use v's and t's instead. Okay, need to find what k and t are. K is the initial value. Okay, so we know initially 14,000. Okay, so that tells me that k is 14,000. Okay, and it's falling or decreasing by 8% yearly. Okay, this tells me that the A value will be 0.92. Okay, so start with 100%, minus 8 gives me 92%, and convert that to a decimal. That's the idea. Okay, so my model for this scenario is the value will be 14,000 times 0.92 to the power t, okay, where t is in years. Okay, always make sure you do this part, defining the variables. So calculate when he would expect the value to drop to 1200. Okay, so I haven't even done part A yet. Okay, so basically finding t when the value is 12,000. So I'll sub in v equals 12,000. Okay, and then I'm just solving for t. So similar to the problem above. Okay, and then get t by itself using logs. Okay, whatever this ends up as, 1.85. Okay, so if you get something like 1.85 years and you want to convert it to years and months and days, okay, 1.85, there's, okay, 1.85. So it's 1 year and 0.85 of another year, so 0.85 times a year, which is 12 months, will get us about 10 months. Okay, so 1 year, 10 months, and 0.2 of a month, so 0.2 of 30 days. So 1 year, 10 months, 6 days, roughly. 1 year, 10 months, 6 days. Okay, part B, discuss the effect of any assumptions that you've made. Okay, so the huge assumption that we made setting up this model, okay, is that the rate stays the same. Okay, we have assumed that the rate of decrease stays the same for how long? The next 2 years. Okay, so if the rate was actually higher, it would decline to 1200 faster than 1 year, 10 months. Okay, final question. Okay, part A. Okay, so we've got a particle moving in a straight line. So again, to get an idea of where this is, I define some origin here. The particle starts at like 6. Okay, so you can think of the person starting here. They go back to the origin, and then they go 4 meters away from it, and then they go back to the origin, and then they keep going away. Okay, this is the positive direction, that's the negative direction. Okay, part A, for how long did the particle move? Okay, we're saying that the particle's time is restricted between 0 and 4. Okay, so it moves for 4 seconds. Okay, since we've restricted this domain. Part B, how far away from the origin did the particle begin? Okay, so just looking at the graph, I can see that it starts at 6. Okay, so started at 6 meters from the origin. Okay, if we wanted to use the formula to find this, okay, I'd find what x of 0 is. Okay, substituting t equals 0 into this formula at the top. Okay, and I get 6 there. Okay, so sub in t equals 0 into this formula. That's part B done. Part D, okay, skip C, that's strategic. How long after it started was the particle to the left of the origin? Okay, so that's looking at when does it cross over? When does it actually move to the other edge? Okay, so I could find this on my calculator. If I graphed it, I could find the intersection point exactly. I'd type the graph in here. So I've drawn the graph in. Okay, I haven't restricted the domain, so we can see it continuing up. Okay, when was it? I can check my answer for part B. What's the y-intercept? Okay, y-intercept was 6, and I can g-solve for the root as well when it initially crosses. So after 1 second, it crosses the line, and then after 3 seconds, it's back in the positive direction. Okay, so I'll just state in part D, after 1 second, okay, since x of 1 is 0, when the particle passes the origin. Okay, part E, what was the average velocity in the first 3 seconds? Okay, so I'm looking for an average rate of change. Okay, first 3 seconds, I could use the points here. Okay, I've got 2 options here. I can just use these points, 0, 6, and 3, 0. Okay, I'm calling this x and this t. Okay, so I'm looking for the change in displacement on change in time, given that I've got these 2 points. T1, x1, T2, x2, okay, and find the difference between these. Minus 6 on 3, here I'll get minus 2 meters per second. Here's my average rate of change for the first 3 seconds. Okay, alternatively, if I wanted to use the formula, I could just find x of 3 minus x of 0 divided by 3 minus 0. Okay, if we weren't given the graph, we'd have to do this, okay, which is going to be a very similar procedure to what's going to happen in part F. Okay, part F is what's the instantaneous velocity after 3 seconds. So part E was this line. Okay, part F is the slope of this tangent. I could try and estimate the slope of the tangent, finding 2 convenient points. Okay, but I'm going to use the formula that's provided and use instantaneous rates of change. Okay, so for part F, I'm going to find instantaneous rate of change, which will be 2 points really close to one another. Okay, and I'm going to need to find what x of 3.01 is, okay, and what x of 3 is using the formula provided, okay, which is t cubed minus 2t squared minus 5t plus 6. Okay, so I'm going to sub 3.01 into these. Okay, and sub 3 in here as well. Okay, I'll get 2 values here, so this one's 0.1 and this one's 0. And now it's just a case of subbing in all these values. And I'll end up with a instantaneous rate of change of 10 meters per second. Okay, once I put all that in my calculator. Okay, so remember for part F, what we're doing is we hit that point at 3.0 and we're putting another point really close to it, which is 3.01 and something else. 0.1. Okay, so the way we're finding the slope of this tangent is those 2 points really close together, which will get pretty close. Okay, that's it, done.